Let's move on to number 5. Now, on this case, we're given standard form again, but they want us to use the x and the y-intercepts. And just recall, to find the x-intercept, it's always what is the x value when y is equal to 0. So in other words, plug in y equals 0 and solve for x. And then, of course, with the y-intercept, we already know what is the y value when x is 0. So that just implies that we need to plug in x equals 0 and solve for y. Now, a lot of us can do this math in our head, per se. I'm going to show the algebra at least once. So if I wanted the x-intercept, what I'm doing is I'm looking for x. So that means I should be able to get rid of y. So we can see 3x would be equal to 24. So then x is equal to 8. And since we want to communicate that this is an ordered pair, I'm going to list it. If I use the y value of 0, I get the x value of 8. So then for our y-intercept, we do the same. We are looking for y, so we should be able to get rid of x by plugging in a known value. Don't drop our negative, and then we can see that the y-intercept is -6. And again, we just communicate that as an ordered pair. So then you just plot those 2 points, and you connect them. And that's enough to make a line, right? We just need 2 unique points to determine a line. Same thing on the next one. If we find our x-intercept, -2x, I'm going to omit 3 times 0 being 0. So we can see here that we get -9. So the point -9, 0. And then for the y-intercept, I'm going to omit -2x equaling 0 because we know that's just 0. So 3y is 18. So y is equal to 6, or in other words, the point 0, 6. So -9, 0, and then 0, 6. And we have our line. Find the equation of the line in point-slope form. So this is just getting us to remember how the formula works and where things go. Now remember, when we're using this, there has to be a minus sign. That's part of the form. So we're going to write it with the minus sign first. And then we see that whatever the y1 and y2 are, or sorry, y1 and x1, those are the values of the ordered pair. So it always has to be y minus something, and then the y value from the point we were given was 2. The slope was 1/3. X minus has to be there, and the x value is -5. And then obviously a lot of times you will see that simplified by changing the minus to a plus. And that would be your correct point slope form. Write the equation on the line and point slope from the passage of the given points. So here we have a point, or we actually have 2 points, but we need the slope. So just remember to calculate the slope. It's the change in y over the change in x, right? So y2 minus y1 over x2 minus x1. Doesn't matter the order as long as you're consistent. So we subtract the y's on top, the x is on the bottom. Watch out for your negative. This is -3, and then this is the number 7. So when we're using our point slope form, it doesn't matter what point we use. So if I was using the first one, again, instead of minus, I'm just going to change that to a plus again. The slope, and then x minus, but the x value is a -5. So a minus and negative is the same thing as a plus. And again, that's the version of the line that uses this point. You could use the other point, right? So y, and then minus the y value, but the y value is -4. So that's just like adding. We have the same slope. And then x minus, and in this case, the x value is 2. So it doesn't matter which one you use. They're both the same exact line. So either one would be fine. Now we'll just kind of repeat that process on letter B. So the slope So on top we get -1, but on the bottom we get 0. Now this is a huge point. We do not know how to divide by 0, so this is undefined. The only line with an undefined slope is a vertical line. So in this case, we have to use the appropriate form of a vertical line, and that's x equals. And as we referenced before when we were plotting the vertical lines, both of these points have the rule that x needs to equal -2. That's the only thing that's going to place them on this line. So that's our final equation. So here again, just more problems. So we have a point, and then we need to get the slope from lines being parallel. So again, we always need a point and a slope for a line. So if it's parallel to this, we need to calculate its slope real fast. So a lot of times we just turn that into y equals form. So 4x minus 6 is the same thing as 3y. So I divide everything by 3, and then I can see that the slope is 4/3. So if the slope is 4/3, I can use my point slope form. So y minus the y value of 2 is equal to the slope of 4/3. And then in parentheses, x minus the x value, but in this case, it's a positive 5. So if we're going to convert that to standard form, we'd obviously need to distribute. And then start to isolate y. And then for standard form, I guess instead of isolating y, what I should say, standard form has x and y on the same side. So I was trying to get rid of this minus 2. So on both sides, I'm going to add 2. And I'm also going to subtract 4/3 from both sides right away. So we have negative 4/3 of x plus y is equal to, and I'm going to convert 2 to 6/3, so 26/3. Now, the last part about standard form, we normally or usually have integer coefficients. It's very common to have integer coefficients, unless we're doing some sort of like application problem, like where I'd want to use decimals maybe for money or something. So here we're going to have to sweep the fractions. All right, we just multiply by common denominator. It's best if you use the least, but any common denominator works. I'm just going to multiply everything by 3. So this turns into negative 4x, this turns into 3y, and the 3 cancels over here just to be 26. So very similar now that we know how to do that with parallel lines. This one just says perpendicular. So lines are perpendicular if they have opposite reciprocal slopes. So we have 2x plus 5y is equal to negative 3. So then by subtracting 2x from both sides, I can see here that I'd be dividing by 5. So if the slope of this line is negative 2/5, we take the opposite of a negative, which turns into a positive, and then we'd flip the numerator and the denominator. So the slope is 5/2. So we'd start with point slope form, so y minus the y value, but since it's a minus minus, we'll just change it to a positive. And we put our slope, and then x minus the x value, which is 3. We'll do the same thing here. We'll distribute. And then we're going to get x and y on the same side. So I would have subtracted 5/2 x from both sides. I'm just going to go ahead and rewrite that with x first because that's what standard form is traditionally written. So if I subtracted 5/2 x from both sides, and then I'm also going to subtract 1 right away. And in this case, I'm not going to combine those fractions because I know I'm going to get rid of the fraction in just a moment anyway. So it's easier just to combine integers rather than fractions. So the common denominator is 2, so I'd multiply everything by 2. So negative 5x plus 2y equals negative 15 minus 2. So then summarizing, we have our final equation in standard form. So we just have a few like application problems on the next page here, just like some important applications and like big words like initial and stuff. So it tells us the cost, which is y value, is calculated using the number of months, and it gives us this equation. So we need to graph the equation below and make sure we'll label and scale each axis. So it's already scaled. Label means words. Scale means numbers. So we have the y-intercept of 75, so that'd be right here. We have to approximate going up 45 and over 1, which is sometimes hard to do. So maybe we should just plot another point. So like you might want to plug something in like, I don't know, I'm just going to pick 5. If I plug in 5 for the x value, this turns out to be 300. So we'll just have this other point like 5, 300. So as long as we have 2, that's 300 right there. As long as we have 2 points, we can always connect our dots to make a line. So we graph the equation. Notice how I didn't extend into the negative x values because that doesn't make any sense. So initial is always associated with 0, and the membership is associating with the y values, right? What's the initial membership? And I think here it should probably say cost. So we plug in x is equal to 0. So if we plug in x equal to 0, that's just the y-intercept. So the answer there is $75. On the next one, what is the cost per month? What does this number algebraically represent? So the cost per month, well, that's y. So y is cost, and x is months. So if we're looking for y over x, that's just the slope. So the slope here is $45. So the cost per month is 45, and what does this number represent algebraically? It's the slope of the line. What is the total cost after 8 months? Again, they just gave us something. Months was x, so they told us to plug in x is equal to 8. So you just go use the formula, plug in x is equal to 8, use your calculator if needed, and it comes out to $435. So last one here, you and a friend are each typing your own research papers on computers. The first function, which I might put a little 1 there, like y1, models the number of words you have left to type after x minutes. And your friend has a different equation because they're typing a little bit differently. Graph the two equations in the same coordinate plane, label blah, 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 blah. How are they related geometrically? Well, the first thing I noticed right away is they have the same slope. So I should assume that they should be parallel. And we'll see that in just a moment. So the same slope here. And when we're graphing these, kind of similar thing, I'm going to start with the y-intercept of like 1400 and 1200. So we can see that they're counting by 100s. So 5, 6, 7, 8, 9, so this is 1,000. So this would be 1,200. So 1,400, let's graph y1, and maybe I'll do y1 in like a blue color. So we start at 1,400. Now going down 50 and over 1 isn't super conducive to my scale. My change in x is 1, but my change in y is 50. So I might want to re-represent that as 100 over 2. So if I go down 100, I have to go over 2 x values. Down 100 over 2 x values. So I'm just going to keep doing that. Then we would connect those dots. Kind of ran out actually. But connect those dots with a straight line. And then for the other one, I can do that in, let's do it in green. We'll do the same exact method. And the same thing with the slope too. Instead of 50 over 1, that doesn't really match my x-axis. It'd be 100 over 2, or it doesn't match my y-axis, excuse me. My y-axis is changing by 100, so I'd rather my change in y be 100. So we'll start at 12, but same thing. If I go over 2 lines, I have to go down 100, so over 2, down 100. What we can see here now is that this is where that idea of the parallel lines come in. We're doing the same pattern for both of these slopes, so we'll never run into each other. We can go back and scale our axes a little bit too. We're counting by ones, so 11, 12, 13, 14, 15, 20, 24, so on and so forth. What are the x and y-intercepts and everything represents? So the x-intercept, well, when x is 0, what is x representing? X is minutes. So at 0 minutes, oh, excuse me, that's our y-intercept. I don't mean to mess that up, but at our y-intercept, x is 0. So that means 0 minutes have passed. So if 0 minutes have passed, that's just y, that's the number of words left. Now, we can also interpret that if I haven't started typing, that's how many words I need to do. But it's also kind of what we're subtracting from, so let's just call it the total words needed. Because if we haven't typed anything, the number of words left is what we have to do. So for our x-intercept, that means y is equal to 0, and y is the words left. So that means 0 words left. So this would represent the time in minutes it takes to finish. And then the slope, well, again, we can kind of think about what we're measuring. The change in y, that's the words, and x is a measurement of time. So words over time, that's how many words per minute you're typing. So it's your typing speed. But realistically, it means 50 words per minute, which I guess I'll abbreviate WPM. Who will finish first? Well, we can see the green line finishes at like 24 minutes, and the blue line finishes somewhere after 24 minutes. So the green line was your friend. And the way that we would explain, we're typing at the same rate, but my friends started with less words. They only started with 1,200, where I started with 1,400. So then it would make sense that the friend's going to finish first if we're typing at the same speed. So that's what we have for today. You could also explain it by saying the x-intercept is, 24 is less than like 26 or 27, whatever it is. But it's nice to look at the equation.